Hello class, this is a video tutorial on integration by substitution. When integrating by substitution, the u substitution is given. Using this with algebraic manipulation, irregular integrations can be evaluated. So let's take a look at these integrations here. You can pause at any time and give this a go yourself. So here we go. So as we can see, we're being told what integration to use. But we can't just integrate it straight away where we go, well, notice how all of this is going to be u. It's going to be u to the power of 9 dx. Notice how it's still dx, and we can't really integrate this unless we had a du here instead. So we do some manipulation here. So we go u equals 5x minus 1 du over dx. That's just 5. We multiply both sides by dx. And we divide by 5. So we get 1/5 du equals dx. It's actually this substitution as well that we're going to use. So let's take a look at what happens when we do this. So I write down I for the integral. Our integral now becomes u to the power of 9. So we've substituted this. And dx is this expression here. So times 1/5 du. So from here, we can actually just factor out the constant of 1 over 5. Like so. And it's from this point forward, we just integrate as normal. So we get 1 over 5 times 1/10 u to the power of 10. And resubstituting back what our original values was. So we get now 5x minus 1 to the power of 10 all over 50 plus c. And that there is our integral. Okay, so with that in mind, you can pause and give the second one a go yourself. But here we go. As you can see, we're being told what integral to use. So du equals 4x cubed plus 1 du on dx is equal to 12x squared. Get du equals 12x squared dx, and 1 over 12x squared du is equal to dx. Now that we have this, we can resubstitute back. So we get the integral being, since this is now going to be u, we get u to the power of half times, this remains where it is, so we get 12x squared times dx, which we will now substitute for 1 over 12x squared du. And notice how these two will cancel each other out. And we are left with just the integral u to the power of half du. And then from here, we just integrate as normal. U to the power of 3 over 2, dividing by the new power, plus c, and resubstituting back in our value. So 2, 4x squared plus 1 cubed but we need to take the square root of that. And this is going to be all over 3. And of course, plus c. All right, so let's move on to our last example. I hope you're seeing how rather simple it is. With just a little bit of practice, you get a lot better at it. But you'll see in this last example, some integrals will actually require further manipulation and substitution. You can go ahead and pause and give this a go yourself, but you'll quickly encounter a problem that we'll get through in this example. So let's start as normal. We get u is equal to x plus 1. We begin as normal, du and dx. That's just 1. du is equal to dx. I hope you can already see the problem that you'll encounter when you try and just substitute everything as we have it. We get, well, this is now u. So it's u to the power of half times x times dx, which we can substitute for du. Notice how now we actually can't cancel out x. Okay? So what we end up having to do is we have to do a bit more on top of what we just did previously. So we actually have to take our original expression and manipulate it so it becomes x is equal to something. So x is equal to u minus 1. So we're actually going to also use this substitution. So now take a look at our integral. Our integral becomes, well, x is now u minus 1. This is now all just u, so times u to the power of half. And dx is now just du. Let's expand this. That's u to the power of half times u. That's u to the power of 3 over 2. This times negative 1 becomes negative u to the power of half du. And it's this that we integrate. Integrating this, increasing the power by 1, dividing by the new power. And we do the same for this one. This becomes increase the power by 1, divide by the new power. At this point, you can do a whole assortment of factorizations that you'd like. But for this, I'd like to just keep it a little bit simpler. We get 2 to the power of 2 outside of u to the power of 3 onto 1/5 u to the power of, well, just u minus 1/3. I'm going to combine these two together, so it becomes all over 15. This becomes 3u minus 5, and this remains the same. And now I just resubstitute back in what our value of u was. So this becomes 2 to the power of, actually no. Oh, I realize I mixed these over. It should be 3 over 2. There we go. This becomes square root x plus 1 cubed times 3 x plus 1 minus 5 all over 15. And bringing everything into one fraction, this becomes 3x, this becomes 3 minus 5, so it becomes 2 x plus 1 cubed times 3x minus 2 all over 15. Oh, and plus c. So I hope that gave you an insight into integration by substitution with slightly more difficult problems. And yeah, I hope to see you in the next video. Best of luck.